All right, recording three, roll in. One detail I forgot to mention with this particle physics. Right. So remember this bell curve? Remember how plus or minus one standard deviation covers 68%, and then plus or minus two standard deviations, it's like 95%, and plus or minus three standard deviations, it's like 99.7%. Right. So and this is like if you see some kind of random data, right? And in fact, the Z table only goes plus or minus 3.5 standard deviations. That's what Z goes to negative 3.49 or plus 3.49. Right? It's like 3.5 standard deviations. Right. Right. So let's tie this back to particle physics. Remember, when physicists say they discovered a particle, it's not like they're taking a photograph of it. They're looking at aggregate data from particle collisions, saying, okay, well, we would expect these types of collisions. Right? So they discover things probabilistically. So does anybody happen to know, maybe on one of these posters hanging from the ceiling, what the particle physics standard is? Like how many standard deviations from the mean it would have to be before they declare that they've discovered a particle?
I want to say from crazy amount like
7. It's five, right? So 5 is typically standard. Yeah, so 5 standard deviations from the mean, which is completely off this table, which means it's something like I think it's like 3 in 10 million chance. It's less than a 1 million chance that you would expect to see that particular data if it was indeed all random, right? So when they, I think it was like 2012, I think it was, they said they discovered something called the Higgs boson, which is one of the last big ones. Right? Yeah, so for them to have made that announcement to declare that yes, we have in fact, because they start off with theoretical physics, say, well, theoretically, they do some normal crunching, we think we should see this particle, and then they go to the lab, they go to the Large Hadron Collider, right? They run a bunch of collisions, like I don't know, millions, billions of collisions, right? They crunch all this data, and if the numbers were statistically random, it would be less than a 1 in a million chance that they would see something like that. It's called a 5 sigma standard. It's like having a Z-score of 5.